Okay, so we're going to have basically, I'm not sure if any of your other math classes have done this in the past, but we're going to be having learning goals just so that at the end of the class, you know what should you be able to do. So this is, like I said, back in grade 9, and it may have been a while since you've done this, but basically what we're going to do is by the end of today, and you should already know how to do this, you can simplify expressions by collecting like terms. So we're going to start from the very beginning. What is a like term? What does that mean? So collecting like terms. This whole thing here, so the way that this is going to work, I'm going to check your binders and your notebooks to make sure that it is organized. Anything that I write on this board, you should write on your note. Isn't that pretty awesome? So anything in a blue pen that I write here, you should write it on there. Okay, because I find it amazing that sometimes my grade 9s, they still don't know and they watch me the whole time. And I'm like, are you going to copy this down? Because it's for your notes to study. Okay, so this whole thing here is a term. Okay, that's what we call a term. Now, a term is made up of sometimes two, only one parts. This part right here, does anyone know what this is called? Just that -4? I'll give you a hint. The word's on the page. It is a coefficient. Very good. So this is my coefficient. The coefficient is always the number out in front, which leaves process of elimination. What does that x mean? Laura? Very good. This x here is the variable. Okay, so I have a term, and sometimes a term is made up of a coefficient and a variable. Sometimes the variable isn't always there. So I have some examples here, and these are good starting points. I have my first example here of 3x. I'm going to go around this class and ask you, and no worries if you get it wrong because you haven't taken math in a while. What is the coefficient? And I'm going to do this to get to know your names. Nick, you like being called Nick? What's the coefficient here? Good. Positive or negative? Good, because when there's no plus sign, it's always implied that it's positive. Jenny, what's the variable here for 3x? Very good. Okay, Danielle, what's the coefficient here? Good. Okay, Carissa, this one's a bit tricky. What's the variable here? Pardon? There isn't one. That's perfect. Great answer. That was a trick question. There's no variable here. Anyone know what we call that when there's no variable? Starts with a C, and it's not coefficient. When we have just a term by itself, this is called a constant. It always stays the same. Variable means that it's always changing. So when you have a term without a variable, that one's called a constant. Okay, Vanessa, this one's another tricky one. What's the coefficient here? No. There is a coefficient. This is a trick one. Oh. Okay, is it Joey? Okay, Joey, what's the coefficient here? For a squared. What would be, so coefficient again is the number out in front. Austin, can you help out? It's 1. Yeah, it's like that secret 1. When there's no number, it always means 1. A lot of students forget that, so don't worry. So again, there's like an imaginary 1 there, and in math, we just don't write that. So our coefficient here is 1. Ben, what's the variable here? Very good. Okay, Enrico? Pardon? Jericho? There you go. Okay, Jericho, what is my coefficient here? 1. Good. Again, there's no number out in front, so I have a 1 here. And Kevin, what's my variable here? Good. And Yulia, what's my coefficient here? Beautiful. And Sarah, what's my variable here? Excellent. Okay, pretty easy? Good. I'm glad. Don't want to intimidate you anyway. So again, these are just the definitions of all of that wonderful stuff there. Okay. Whew, this is a Frere model. Have you ever seen that before? Okay, we are going to, let's see if this works. No. Okay, we're going to talk about like terms in here. So I want you to write that out. So what is a like term? We know what terms are. They're made up of variables and coefficients. What is a like term? Anyone remember what like terms are? If I said that? Oh, you're breaking my heart. Anyone want to take a guess? Wait. Okay, wait. Rob. Yes. That's awesome. Number with the same variable. Shoot. Why aren't you working? Oh, maybe. Oh, wait. Now it's supposed to be working. There you go. Look, how fun is that? It's amazing. Okay, like terms are terms that have the exact same variable. And now that we know what variables are, they're the letters, life is easy. Okay, I always teach my grade 9s, which I haven't taught any of you grade 9. The steps to collecting like term are 2. 1, you group like terms together. 2, all you do is add or subtract the coefficients. Ooh, that's a lot of math language there for you. Absorb it. Okay, once everyone's finished copying this down, I'm going to give you some examples, and I want you to put them, so I have here examples, non-examples. So I'm going to give you a pair, and I want you to put it under, this is an example of a like term, or is it a non-example? Does that make sense? Okay, let's try the first one, see how you do. Okay, so examples, non-examples. Your first one is x and 5. So x is a term, 5 is a term. Is this an example of a like term or a non-example? Laura, what do you think? Are x and 5 like terms? Good, why? Constant, so close. Yes, constant and then one has a variable. So this doesn't have a variable, this has a variable. Wonderful. That's a non-example. Okay, let's try the next one. Nick? I have x squared and 2x squared. Are they like terms or not like terms? Why do you say that? You're right. Yes, you are right. You're going to tag team that? Okay, you got to high five her in though when you do that. You got to high five in. There you go. Okay. Okay. That's okay. So if it has a what, you're right. It does have a 1 in front. They do. Everything has a coefficient, so you're right. But the key thing here is that they have the exact same. Perfect. They're both squared. Okay, ready for the next one? Danielle, you're up. 3y and 2y squared. Are they like terms or not like terms? Are they exactly the same? No. Right, so they're not like terms. And another way that I like to think of this is like spelling last names. It's they don't have the same last name. One has a square, so one last name might end with an E. One might not end with an E. So for example, my last name is Tycolis. I have second cousins who spell it with an S at the end instead of a Z. So it's kind of weird like that. So you're always looking for the same last name. Is it exactly the same? No, so that was another tricky one. Okay, another example. Carissa, 2xy, 3xy. Is that an example of a like term or not an example? Very good. Why? Excellent. 2xy, 3xy. The variables are exactly the same. Are we feeling okay with this so far? Okay, how about this one, Vanessa? Why aren't they like terms? Good. Yeah, they aren't the exact same. Here, the squared is with the x. Here, the squared is with the y. So they are not exactly the same. So these are not like terms. Okay? So we've talked about terms. We've just been able to figure out which ones are alike, which ones are not alike. Are we okay with that? All right. Now we're going to get into some examples. So I had there for my 2 steps is, 1, you want to group like terms together. Now, if you're not good at algebra, that's okay. What I get my students to do you have to do this? No, but if you know it's going to help you, then do it. Inside your bins, I also have highlighters, so if you ever want to use a highlighter, you can use it. Just make sure that I get it back. There's no 5-finger discounts here, okay? Because then you won't have it for the next day. So it says here, I can simplify expressions by collecting like terms. What I need to do is figure out which like terms, where are my like terms? So, Joey, what are my like terms with, I'm going to start with negative 5a. And when you're doing this, you always want to look in front. Is it positive or is it negative? So what else is a like term besides negative 5a? Do they have the same variable? So then, okay, so is it plus or minus? Good. Is there anything else that is a like term there? Is there anything else with an a? Beautiful. I like that you said plus a here, minus a here. Oops. Okay, so I'm highlighting them so it's a visual representation that you know that those are like terms. Austin, my like terms with negative 2. What is a like term with negative 2? Good. I love that you said negative 12, you're looking in front. Positive 1, you're looking in front. Ben, what are my final like terms? Good. Excellent. So right away I've color-coded this. I have yellows, greens, blues. So I need to group them together. How I'm going to group them together is I'm going to write my yellows first. So I'm going to write here negative 5a plus 3a plus a minus a. So I've taken care of each one of these yellows. Are we okay with that? What do you think I will write next? Jericho? Okay, so I'm going to write negative 2, negative 12. Anything else? Oh, no, I'm missing one. Negative 2, negative 12, and good. And Kevin, what's the final thing I'm going to write? Good. So now physically, what did you do? You moved all like terms next to each other. I have all the A's here. I have all the constants here. I have all the B's here. How many of you have calculators? Okay, can you take out your calculators? If you don't have a calculator, you can come borrow one from me right now, but I need it back. And this will be the only day I'm going to let you borrow it. Yes. You're welcome. Thank you. Does everyone have a calculator there? Carissa, do you have one? Okay, so we've grouped all of our... You're welcome. I've grouped all of my like terms together. Now what I need to do, my second step, is I need to add and subtract the coefficients. So I need to take care of my A's here, remembering that when there's no number in front, it's always a 1. So, Yulia, what will I get for how many A's are there altogether? What would you put in your calculator? Perfect. And what do you get when you do that? Who said that? You're right. Yep. So I'm going to put -2 and then A. And Sarah, right? Sarah, what will I get for my next part here? What will you plug in your calculator? Good. What do you get? Very good. What I loved about what Sarah just said is that she remembered to look in front here. This 2 was negative. A lot of times students forget to look in front, and they would put just 2 minus 12 plus 1 in their calculator and get the wrong answer. So you always want to look in front. Rob, what do I get for the last one? Yep. Perfect. Plus 2b. Now, if you were to look at the answers in the back of your book, it's not going to be arranged in this exact way. Anyone know how we should arrange our answers? Austin? Pardon? Okay, so we'll say it. Not always the positive first. You're thinking standard form. What else is there? Rob? You usually do it in alphabetical order, and then your constants are last. So what you would normally see is -2a plus 2b minus 13. Are we okay with that? Okay, let's do this next example. Okay, what are my like terms, Laura, with my, I'm going to start with my first one. What are my like terms with 5v cubed? Pardon? But I got to be careful. What do I have to do? I have to look. Good. So I'm going to include that negative because I don't want to forget it. Nick, what's my next set of like terms here? Good. I have a -v, a -v. Excellent. Jenny, what are my final like terms here? Beautiful. Okay, so when I'm grouping these together, Danielle, what will I write on my next line here? Perfect. You're an all-star. Okay, Carissa, you're up. It's a tough act to follow. What do you do next? We've grouped them together. Good, so what will I do here? What do you get? Good, so I write -7. -7 what? Perfect. Okay, Vanessa, what will I write after -7v cubed? So I've just taken care of this. Okay, let's do that math. Yeah, which gives me? Good, so I write -2v. So I like that you remembered that when there's no number in front, it means the number 1. And then, Joy, what do I write after that? I've taken care of my v's. Yeah, why? Perfect, excellent. Okay, that is awesome. Okay, are you ready for it? You are going to try this out on the desks. So, get your marker, get your eraser. I want you to try this out. Okay, so again, just as a review, I need to see that you're grouping this correctly. I know a lot of you may be able to do this in your head. It's going to get very, very confusing if you don't group it. So I should be seeing something like this. 4x minus 6x plus 3 plus 8. Don't separate it out. Don't make more lines. Yes, Nick? Yep. And then you again add and subtract the coefficients, 2x plus 11, which all of you got, so yay to you. Okay, try this one out. Again, I want to see them grouped. And count them. So copy out the question and go. On the desk, Ben. All right, so again, going through this, I saw a lot of good things. A lot of you showed me the step of you grouping it together, which is 3x squared grouped with the -x squared plus 5x plus 4x plus 3. When you are adding and subtracting the coefficients, you're left with 2x squared plus 9x plus 3. So I think all of you got that, right? Okay, now try this one out. Double check your answer. Look on the board. How's it going? Double check this. Look on the board. What does that say? Yep. Are these exactly the same? How many of you had the same answer as the person sitting next to you? Well, you have another person too. Do you know each other? Have you introduced? Okay, what's the tricky part about this one? Why is this one a little bit trickier than the other one? Oh, okay, all the terms didn't have variables. They were all different. So how did we group this? Can someone raise their hand and tell me how did you group this? What was your next line that you put together? Laura? Cubed, good. Excellent. Okay, how many of you had this line written out? Okay, typically we do, again, would I mark you wrong if you had the plus 4 at the back? No. But in an answer solution, your exponent should be descending. So you always want to start with the highest exponent, then work your way to the lowest exponent. Some of you got hung up on this part here. What was the first thing? So we've grouped them together. When I add or subtract the coefficients, what do I get in the answer here? What would be my final answer? Jenny? Beautiful. So again here, this 5x cubed didn't have any pairs with it, so I just bring it down. Same with that plus 4x, I bring it down. And again, my exponents are in descending order, so that's all good stuff. Are we okay with that? Yeah, geez, guys. Thank you. I know, I must have seen the 7 and just did it. Sometimes I do that, making sure you're on your toes. Good job, Vanessa. Okay, and then our last one that we're going to try on the desks. So give it a whirl. Okay. What did you notice about this equation here? Ben? It was already in order, meaning that all of your like terms are already grouped. So that made it really, really easy. So what was the only thing that you could do here? Jenny? Good. Those were the only like terms there. So what's my final answer? What did I get for my final answer? Someone other than Jenny. Vanessa? Good. Do you have to put that -1 out in front? No, you don't have to. It is. Am I going to mark you wrong? Absolutely not. Just in the textbook, if you don't see it, it's always implied there. Okay, so that is